last year October. Unfortunately, couldn't go to the Europe one, but there's another one happening again in Chicago this year, and I hope to attend. So that's a short background about me and how I got started. Yeah, to get started, I first started with obviously AWS. Moved on to Kubernetes as I saw most companies and large corporations were starting to containerize their applications. Fell in love with Kubernetes, and now basically my full-time job is basically writing custom controllers in Golang, and that's what I do on a day-to-day basis mostly. And funny enough, ArgoCD is a controller, Kubernetes controller, so I also help contribute to the ArgoCD project and Argo Workflows, which is a sister project to ArgoCD. Cool. So the agenda today is going to go over some GitOps fundamentals, the ArgoCD basic concepts, ArgoCD's architecture, ArgoCD's demo, and then how we can use ArgoCD on multiple EKS clusters. This is a beginner's course. So if you are experienced with ArgoCD, you might not get too much out of it, but we start somewhere and then we're going to have future lessons. We can get deep into ArgoCD about how to run it in HA, how to scale it, how to all the different things you can do with ArgoCD. But having said that, I have assumed some basic knowledge, which is some basic Git knowledge, AWS knowledge, CI/CD basics, and some Kubernetes basics. Even if you don't have all four of these, I would still recommend to stay along. You can still get something out of it, but I won't be going over the fundamentals of Kubernetes. I'll just assume some knowledge. Cool. So getting into GitOps fundamentals. First of all, the question is, what is GitOps? So GitOps uses Git repositories as a single source of truth to deliver your infrastructure as code. So I think as we've already seen in the industry, like most of the infrastructure now it's running in the cloud has moved to becoming declarative, so as code. So the likes of Ansible came out, the likes of Terraform has come out, Kubernetes came out, which you declare. And all these things have one thing in common, is you're declaring your infrastructure or your application resources or everything as code. No longer the days where you have bash scripts and things get run and never seen again. So what happens that now we're declaring all our things in code, it would be a nice way to get these things. Every time you push your infrastructure as code or your application Kubernetes to a Git repository, something kicks off. There's a loop, something deploys automatically. So Terraform, for example, IC. Just having Terraform code in a repo itself is not GitOps. But a small example, if you had Terraform code and then you had a GitHub action that every time you push your Terraform code, it automatically ran some Terraform pipeline to deploy it, you could consider that as GitOps. So GitOps is a set of practices. It's not a single thing. It came about with Kubernetes, as we'll get to why the GitOps fits very, very well with Kubernetes, but can only be used in Kubernetes. What do you get out of GitOps? You get a standard workflow for your applications and your pipelines. You can imagine all your infrastructure, all your application logic is going through the same pipeline. You define it in Git. Every time you change it in Git, something happens, it gets applied, it gets changed. You increase the security of your application because you get the power of Git. You have to do PRs, comments, branches, all those powers. You get automatically benefit them in your infrastructure now. Again, you get improved reliability and visibility because you can version your infrastructure with normal Git, and then you have consistency because of this looping feedback that we'll talk about now, because every time you make a change, so you can always see when you go to Git and you go to the right branch, whatever you see in Git will be what's in your cloud or your application and so on. So how to achieve GitOps? There's four main things. We said, again, we need to declare everything. So everything you do needs to be declared in some sort of file, and that this file must be stored into a GitOps repository. Be that your Terraform code, your Helm charts, your Kubernetes manifests, as blank as they are, anything, your Ansible scripts, whatever you want to do, infrastructure. Versioning, so Git, push it to Git, auto pull. So what that means in true GitOps fashion is as soon as you push something to Git, you have another mechanism that's automatically pulling it and actioning on that. So in the feedback loop, as soon as you push, something's pulling and actioning on that change you made, so that commit you made. And then that looping feedback is what I'm talking about, of constantly making changes. So that is what GitOps is. It's a set of principles of how to deliver infrastructure as code. It was first coined, I think, in 2017 by a company called Weaveworks. They delivered a product called Flux, which is also a GitOps engine for Kubernetes, which is very similar to ArgoCD, but not similar. ArgoCD has kind of surpassed Flux, in my opinion. So how does GitOps work, and why does it work so well with Kubernetes? So Kubernetes basically is a set and a series of controllers. Everything you see on Kubernetes is run by controllers, absolutely everything. And that means you have a desired state and activate. So you observe, Kubernetes analyzes, and Kubernetes acts. So you can imagine if you got a deployment on the left-hand side here, you deploy this, you write it to the Kubernetes API server, there's a controller watching it. It sees, okay, you want to deploy your to-do list app, and you want 3 replicas. That controller then will action about that and deploy it. If you change the replica, there's another controller that's watching, and you say, okay, well, you want 2 replicas of my app. That controller changes the replica and creates 2 pods instead of 3. So, and because Kubernetes allows you to create your own controllers. So in Kubernetes now, since 1.7, you can define your own CRDs. A CRD basically, think Kubernetes is a deployment. You can define your own one, and we'll get to ArgoCD has its own CRDs. So you can define your own application on your own thing, and you can create a controller that continuously watches this file or manifest. So almost everything in Kubernetes is declarative. So I'm going to write this to a Git repo. If I change and I push it, something is going to watch, it's going to observe, act, and analyze. And this loop never ends. And this is what's made Kubernetes so popular. And the ability to make controllers, your own controllers, is what I think is what's pushed Kubernetes above any other container orchestration platform, and why it's almost like the go-to platform these days for running containers in the cloud. So now that we know what GitOps is and why it works so well with Kubernetes, introduce ArgoCD. So ArgoCD is exactly what you said. It's a declarative GitOps delivery tool for Kubernetes. So I mentioned earlier that GitOps you can use with Terraform, Ansible, but ArgoCD is specifically for Kubernetes and how to get your Kubernetes resources, so your deployments, your pods, your services, all those things from Git to your Kubernetes cluster. It joined the CNCF as the incubator in 2019. So the CNCF is the Cloud Native Compute Foundation, which is basically an organization which observes all open source cloud native tools. It graduated by the project. So CNCF has different levels of things. You have incubating, graduation. So these are just basically the maturity of the project. And ArgoCD reached full maturity at the end of last year. CNCF did a survey in 2022, and 50% of respondents said they are running ArgoCD in production. In my opinion, ArgoCD has become the de facto way of deploying to Kubernetes. In the past, people have used tools like Kubernetes, like AWS Code Build or Jenkins or Circle CI. But you can imagine with those tools is you have to write some script or something, so be either kubectl apply or Helm install or customize. You just do it once, and it's almost like a fire and forget. So I'll do a Helm install, but now imagine someone goes onto the cluster and changes something. The Jenkins or the Circle CI, I think, is not natively going to pick that up. So it's not a GitOps. There's not that continuous feedback loop. And now ArgoCD is exactly that. And that's why most people today are using ArgoCD to deploy to Kubernetes. Some interesting facts about it is that it's got 13,000 stars in GitHub stars, which is quite incredible. And it's got over 8,000 individual contributors from over 2,000 organizations. So you can see it's a massively open source project, which is span across the globe. Cool. So now that we know what ArgoCD is, we're going to do the basics. So today we're going to go over two basic concepts of ArgoCD. What is an application and what is a project? So the manifest or the file you're looking at here is a COD, a custom resource that you can create in Kubernetes. And this API version comes from the Argo project, and it is an application. An application just tells Argo two things: where in Git must I look, and where must I deploy what you want. Pretty as basic as it gets. So you'll see it says here, this source comes from this repo. The branch is the head or the master branch, and the path inside that repo is where my code or my application's resources are. And I want you to deploy that to this server. This is itself, because Kubernetes also runs inside a Kubernetes cluster, but this server can also be a remote cluster. So, and then what namespace in Kubernetes. And that's the fundamental of an application. Obviously, as a source, ArgoCD supports multiple sources. So what you see here is just a path or a directory saying, hey, this is where my manifest files are, my Kubernetes manifest files are. But you can point it to a Helm chart, it can be customized files, it can be JSON-net. There's quite a variety of what ArgoCD supports. But all of these have to be manifest that you want to deploy on Kubernetes, because Kubernetes, as you said, is just a whole bunch of YAML files that you want to deploy. And then another basic concept is a project. A project is basically just a grouping of applications. So you can think of all applications belong to a project. And this is very good for if you want to do cross teams and allow, like as the DevOps engineer, you're going to supply your developers with an ArgoCD and you're going to allow them to deploy their applications. But obviously you don't want to give them free reign to the cluster. You don't want them to be able to clone from any single open source repository. You want to confine them, and you want to split teams into different developers or into different projects and so on. So that is what a project is. You can see the source repos. You say, I'm only allowing the source repo. So any application that belongs to the ArgoCD project can only clone from this repo, for example, which is my repo, and it's only allowed to deploy to the ArgoCD namespace in this cluster. So if someone creates an application that belongs to the ArgoCD project and tries to clone from, let's say, another repo other than this one, my one, it will say access denied, you're not allowed. You can also whitelist what they are allowed to deploy. So by saying star, you're saying you can deploy any type of Kubernetes manifest, but you can limit them saying you can only deploy a deployment, or you can only deploy a stateful set or a pod or a config map or a secret. You can fully decide, and you can decide if it's cluster wide or namespace scoped. So as normally the admins of ArgoCD are the ones that manage the projects, and then developers themselves create applications to deploy their app. And those are the two basics. There are more concepts of ArgoCD, but those are the two basic ones.
Well, Kelvin,
so, sure.
Just before you proceed, just a quick question. Why would you do that segregation on who can deploy applications, or, you know, just why would you choose to do that, especially in a very big organization? What would be the logic behind segregating that?
Sure. So one of the most common use cases for ArgoCD is to manage multiple environments. So you can imagine ArgoCD manages your developer environment, your QA environment, and your production environment. You don't want to give everyone access to deploy to your production. So you'll create a project for production and only allow certain people or certain times of the day where you can deploy to production. You can control that on the project. And then you'll have a dev environment where you can pretty much say, fine, dev is open source. You can deploy whenever you want. You can deploy any type of resource. You can choose any source. But obviously for production, we want to keep this very safe. So projects are also I've seen them used two ways: to segregate different environments and to segregate different teams. Because on ArgoCD, when you create like a you create users, and when you log into users, you can group users based on projects. So when you log into ArgoCD UI, which we'll get to soon, the developers will only see the projects that belong to them. So imagine we had a big organization in that example. We had we only had one ArgoCD, for example. If I'm a developer, I want to log in. I only want to see the apps that belong to me. I don't want to see the entire org's apps. So I'll group it to a project, and then when I log in, I'm only going to see what's related to me. Obviously, the admin will be able to see everything, but it's a nice way to split things up. That's the two use cases.
Okay, that's great. I think it also enforces some level of security as well, because you also don't want to expose environments to people who probably shouldn't have certain access to certain environments as well.
Definitely. Exactly the way we should be used. So projects is a good way of doing like multi-tenancy and segregation across things. There are multiple ways of how to configure concepts of how to deploy ArgoCD. Like we'll get into that later, but some people use an ArgoCD per environment, for example, but we'll get to that a bit later. Cool. Moving on, this is just a quick architecture of ArgoCD, and thanks to Lukande, my good friend who actually works at AWS. I stole this diagram from him because I saw him had it, and it was a perfect little diagram. So this is under the hood how ArgoCD works. There's three main components. There's the ArgoCD repo server, ArgoCD application controller, and ArgoCD server. All three of these are microservices that run on Kubernetes itself. The ArgoCD server is basically the UI, what you're going to see mostly today. So when we click around, see everything, this is the UI you're seeing. The next part is the application controller. This is the part that actually connects to the cluster that runs. So you have a manifest, you have a deployment manifest. You know, if you're a developer, you normally write kubectl apply, and then you give it the manifest, for example. That's the job, or you do Helm install. That is the job of application controller. It will write this manifest to the Kubernetes API server using the Kubernetes API server API. So its job is to connect it. As you see in this example diagram, it's connecting to the stage EKS cluster, it's connecting to the prod EKS, and it connects. And also the one that does the reconcile. So it's applied this manifest or this application to the cluster, and it is now in a constant loop checking as what you've defined in Git and what I've deployed, is it the same? If it's not the same, it will tell you. And it basically loops all the time. Well, you can configure how often it loops, which we'll get to. And then the ArgoCD repo server. So as we said, everything comes from Git, but when under the hood ArgoCD run, like this needs to store these manifests somewhere. This is the job of the repo server. So if you're doing like Helm, for example, ArgoCD will run Helm template, which will produce all the manifests. That will be the job of Argo repo server. It will then store these manifests inside a Redis cluster. And the reason it does that is just purely for performance. You can imagine every time it does this reconcile, we can't expect the application controller to continuously go to Git and then render the manifest again and then check a cluster. The performance will be too slow. So it temporarily stores them in Redis, and then it uses Redis to compare what's in Redis to what's on the cluster. And how do we update? Because now you're saying, oh, who are you doing GitOps, Kelvin? I thought we're checking Git every time. So how do we invalidate? Because Redis is a key value database. How do we invalidate the cache here? So say I push a change to Git. How do I update Redis to get them to render the manifest again to do the GitOps? So the repo server is continuously watching Git. This is continually watching. If the repo gets a new commit, basically the key in this Redis server is the commit hash. So basically, every time it sees a new commit hash inside Git, it will then invalidate Redis and regenerate the manifests and store them there. That's why ArgoCD is actually stateless. Like it's okay if you destroy ArgoCD and recreate it, because there's no persistence. Redis just gets regenerated every time. Like if I had to delete the Redis and recreate it, the application controller will see, oh, I have nothing in manifest, goes to the repo server, it does all the things, Helm, template or just pure manifest, and then saves them in Redis. And then that's how, and this loop here, basically what you're seeing now, reconcile, is the loop, the control loop that we continuously talk about. The controller talks to Redis and continuously loops back. So that is the basic architecture of how ArgoCD works. I think it'll make a lot more sense for the when we're doing a demo. So let's jump into the demo.
Before the demo, Kelvin, can we just check if we have any questions, maybe from the guys on the call, if they have any questions specific to this architecture that they would like you to speak to. Any questions, guys? Don't be shy. Okay, cool. Looks like we're good.
Cool. We'll do a demo and then we're going to talk about ArgoCD and EKS specific, because there's a few nuances there that you will encounter. So I have a ArgoCD app. So if I just, how do I move this thing out of the way? Okay, well, it should be, nope. Sorry, let me just get this thing out of the way. It's quite annoying.
Sorry, I actually have a question with regards to the synchronization. How does ArgoCD, do you have to like sync it manually every time you like make changes, or you want to make a deployment, or how does it know that now maybe there's new changes that I need to deploy, for an example?
So there's two options. So by default, if you install ArgoCD fresh out of the box, it goes and checks with Git every 3 minutes basically. So it checks Git every 3 minutes to see if there's any changes. But obviously in a production environment, you wouldn't like that. So you can configure like webhooks, like in GitHub, you can configure webhooks, or you can use a code commit as well. You can configure, which tells ArgoCD, hey, something's changed. And then when something is changed, ArgoCD will have this thing which it says out of sync. This is an example of application. You can tell ArgoCD enable auto sync, but now it's disabled. So you can see if ArgoCD picks up a change, if enable auto sync is enabled, it'll automatically apply that change, or it will wait for a person to come and sync. And this can be useful in terms of like production, when you say you want to deploy at a certain time of the day, like when customers are not busy, so like in midnight or something. So you can do a manual. You also do as projects, because projects also have this thing called sync windows. Basically, you can say people can only allow them to sync at certain times of the day. So as the admin of ArgoCD, I can say, hey, you're allowed to auto sync between midnight and 2 a.m. Other than that, we're not going to allow syncing. So there's those options. We can, if you're in a completely CIC world, like where you basically deploy multiple times a day, if that's your organization setup, then you can imagine that your organization will have this application set to auto sync. But many times you'll have this disabled, and a person will come here, and then there's a button here, you can just hit sync, and then it'll take whatever changes in Git and apply it to the cluster. I hope that answered the question.
Yeah, no, you actually did. So if I understand you correct, you can correct me. So ArgoCD is more like your, as the word says, like it's more like your continuous deployment. And then I would assume we'll have to have, like in a normal environment, you'll have to have like a tool that will manage the CI portion of things, right?
Exactly. So ArgoCD is, as I said, CD. It's just doing a continuous delivery. There's many, so it does not do the CI part of it to build your application. That you need either a Jenkins or an Argo Workflows or Circle CI, code build, AWS code build. all of those are valid options. And then there's a way, which we're going to talk about at the end, is what's the best way of how to link your CI to CD. There's very good practices of how you should do it, and there's many ways of doing it actually to link your CI and CD with ArgoCD, which we can also discuss at the end. So I have deployed ArgoCD already. I actually might just do this because this is so I can see at the top of my screen now. There we go. So ArgoCD itself is an application that runs on Kubernetes. So if you have to go to the Getting Started guide, you'll see it is just you create your ArgoCD lives in the ArgoCD namespace, and this is basically the manifest. You just need to say kubectl apply this. Obviously, when you're doing production management of ArgoCD, this is not how you'll do it, but this is the Getting Started. And this is pretty much what I've done for this demo. Almost the same. And now I've basically just logged on to the default ArgoCD. I have installed some apps, which we won't go too much, but I'll just do a quick run through of the UI. So ArgoCD, this is obviously where you'll see all your apps. And yeah, you can filter between your projects as we discussed. So when you deploy ArgoCD, first you'll get your default project, which is always there, and then your ArgoCD project, which I created. And then your clusters, right now I only have one cluster, which is itself. ArgoCD is deployed in itself, and it can deploy other applications to the same cluster. Settings. So repositories, obviously ArgoCD needs to connect to Git. So right now it's connected to my repo, and I've provided credentials. And you can connect right now to a Git repository. You can connect to a Helm repository, Google Cloud, and yeah, you should have to change to Helm. But one thing I do say is there's Helm. You'll see, yeah, you can connect repo, and you can create new apps. Never do that on the UI. ArgoCD can manage itself. It's because everything on ArgoCD is also defined in a YAML file, is declarative. So from repositories, which we'll get to applications, clusters, everything can be defined in a Kubernetes manifest. So don't do things manually. If you're going to manage your entire environment declaratively, manage ArgoCD declaratively. But don't create apps. So we'll show this now. So settings, what else is it? This clusters, we will add some more just now. Projects we've spoken about, counts if you link a count, and then appearance. That's bare basics. So if we had to go to, I have a simple app here that I want to deploy. It's a simple application. It's an Nginx application. I just want to deploy it in let's just say the default namespace for now. The project is links the default. It's linked the manifest of all my, I want to deploy this deployment. So I'm telling the application, hey, this is where it is. This is the path that's in. This is the branch. So if I'm here, I can just kubectl apply this application, which there's also many practices of how to manage and how to deploy your ArgoCD applications onto your cluster as well. There's many different ways of doing it, which maybe we can get to in a ArgoCD advanced selection, which is you can do app of apps pattern, you can do application sets, variety of ways of how to manage applications. But for now, I am just deploying a simple, and it would help if I was, let me just go, I don't have a default namespace. Okay, I don't have ArgoCD namespace. I might actually connect to the cluster.
Cool. While you do that, I think
Sure.
I'll also just ask, what level of Kubernetes skills would you say someone needs to start working with ArgoCD?
So I would say you would need the basics. So you need to understand the concepts of Kubernetes, which is like your pods, your deployments, how Kubernetes is a bunch of series of controllers. Understand what replicas are, what a pod is, what container is, what a Docker image is. Like just understand the basics, and you should be able to easily grasp ArgoCD. You don't have to be an expert at Kubernetes, but to see the true power of ArgoCD, it's very beneficial to know what's happening in Kubernetes. When demo fails, but that'll always be fine. There we go. So So for example, see, this server is not allowed, is not permitted in the ArgoCD project. So that's actually great. So we can just go to projects and we can say destination. I'm going to say all for now. This is not how you should do it, but today we're going to just, I want to go cool. So now you can see if I hit app diff, which is saying on the left-hand side, it's saying what is on your cluster. The right-hand side is saying, what do you want to deploy? I want to deploy a deployment onto my Kubernetes cluster. So if I hit sync, it's now deploying my Nginx application into my deployment. And now let's actually have a quick example and go onto this cluster. This to show you how it's a GitOps engine. So we have now, this is our new Nginx, which came up 29 seconds ago. For example, say I edit this and I change the replicas to 2. Cool. So it's automatically saying app diff. You can see it's saying, hey, you've deployed 2, but Git says you want 3. It's telling you what's different. But you can see I haven't set auto sync. So it's not going to automatically go back. It will wait for me to hit sync. I can refresh it to one of the downside here. And if I hit sync, it will deploy the third one. And a great example also as if now I'm in my repo and say we're going to now go to our Nginx and we have our CI. Our CI has rebuilt our Nginx and now I need to change the tag of Nginx. I need to change the image. So I'm going to just commit this like a normal Git. So this is how you would have a CI process that does this. Git commit, it'll say releasing latest version of Nginx. I've pushed it. ArgoCD is going to, if I refresh, because by default, remember I said by default, it checks every 120 seconds. So I don't have any webhooks configured. But if you hit refresh, you just tell the repo server, hey, go to Git and check if there's any changes. Like you're almost like forcing a reconcile. And in this case, we do. You'll say, hey, I've deployed this version, but Git says I want this version. And then you hit sync. And that's how you deploy a new version of your application. And you can see it's bringing up new pods. And because Kubernetes is doing a rolling update, boom, boom, boom. And that's pretty much how you ArgoCD. There's some other nasty nifty UI features of ArgoCD that are very useful. So on ArgoCD, it allows you to see the logs of your application, which is very useful. In certain cases, it allows you to actually shell into your container if your container allows it and you've allowed it on ArgoCD. This is also all controlled by permissions. So that is the basics of ArgoCD of how. One thing I also wanted to mention quickly is ArgoCD is an application itself, as I mentioned before. So you can manage ArgoCD with ArgoCD, almost like Inception. So like you'll see here, I have ArgoCD, and in this example, I'm using Customize, which is just another way of managing Kubernetes manifests. And I have an application that says, hey, follow this path, ArgoCD install, and whatever inside there, change. So you'll see I have my Git credentials, I have ArgoCD config maps, I have all the other fun things. I have a dev cluster, which we're going to add soon. And I'm using Customize, and ArgoCD can understand Customize. And I'm deploying version 257 of ArgoCD, and you'll see we have version 257. So ArgoCD is itself an application which we can monitor. If I had to just filter here for pods and show you all the only pods that are running in Kubernetes are obviously the ones I've mentioned before. So remember that architecture I spoke about before? We have ArgoCD Redis, which is the Redis. We have the repo server, which is generating these manifests and storing it into Redis. We have the ArgoCD server, which is this thing itself. And then we have the application controller. The other things are newer features in ArgoCD that we haven't discussed yet. ArgoCD notifications is quite straightforward. So you can configure ArgoCD to send you notifications to Slack, to Teams, email even. So imagine ArgoCD can also tell you if your app is unhealthy. So you can configure what's healthy using a variety of metrics, and then it will tell you if it's unhealthy. It can also send you a notification when something's been synced or when something's been out of sync. The deck server is if you want to configure single sign-on with ArgoCD. So the UI right now, I've just logged in with the username and password, but you can connect this to Cognito. You can connect this to Azure, all those fun things, Google, and then application set controller is a topic we won't get into today. Cool. We are running out of time and we haven't touched AWS yet, so let's jump quickly to AWS if there are no questions.
Cool. Just before we go on to there,
Sure.
can you just go back to that VS screen? So where your YAML is.
Yes.
Yes. So the Git credentials, is there another way to feed those credentials without necessarily, putting them in the YAML file and then pushing that to a repository?
100%. So yeah, so obviously I won't show the Git credential file now because I've got my Git credentials in, but yes, in an ideal world, you would not want to store your credentials in Git. And there's a variety of ways of doing this. So depending on what your file is, so you can see I'm using customize. So you can encrypt your file. So this Git thing, you can encrypt it with anything. So there's a tool called SOPs, which you basically can use SOPs to basically encrypt any file, and then you push that to Git, and then you give access to ArgoCD to this key, which encrypts your file, and then ArgoCD on the fly knows how to decrypt the file and then apply it. So what you see in the Git, what you see in Git is just an encryption file that no one can decrypt other than you and ArgoCD. That's one option. That's the option the reason I like SOPs is because it allows you to do GitOps with your secrets. Another solution is there's another thing called secrets, external secrets in Kubernetes. So basically you install your, you put your secrets in like AWS Secrets Manager, and then you tell Kubernetes obviously, hey, my secret's here, go fetch it. And this way you don't actually push this Git credential file to Kubernetes or to your repo. So those are the two ways. There are a variety of other ways, but those are the two most popular. Today I've just pushed Barebone just for the demo.
Okay, cool, awesome. I see you can also use HashiCorp Vault.
Yes, you can.
Okay, great stuff.
Cool. So let's go back to the demo. ArgoCD on EKS. So there's like I said, there's many a variety of ways to deploy ArgoCD. So I remember I said you can either imagine you have multiple clusters in your organization. You have a dev cluster, a QA cluster, or a prod cluster. Some solutions are to deploy ArgoCD in each one of those clusters. The pros and cons, and we won't go into the details of today, but there's a lot of trade-offs of either solution. Or you could have a single ops Kubernetes cluster, which then manages other clusters. And this ArgoCD deploys into dev, QA, and prod. And this is a very common use case. And for small organizations or small companies or small teams that do have a few clusters, I think this is a good approach rather than managing multiple UIs, multiple ArgoCDs, because it just becomes more of a maintenance headache. But obviously, your blast ratio can be a bit more big if your single ArgoCD goes down. So there's trade-offs, which you also can configure ArgoCD in HA mode. ArgoCD does have limits, but those limits are quite high. Like I've run Kubernetes, I've run ArgoCDs with thousands. I'm currently running ArgoCD with thousands of applications, and it performs really well. You can tweak ArgoCD of how you want to do this performance. So having a single ArgoCD to manage multiple clusters is a very viable solution. But now in AWS world, we know how do we allow one cluster to connect to the other cluster with credentials. ArgoCD needs access to dev, QA, and prod. So how does access to EKS clusters work? How do we map IAM principles to Kubernetes RBAC? So in RBAC, you have you control permissions to Kubernetes clusters through RBAC, cluster roles, service accounts, role bindings, those things. So we want to try and map our IAM cluster, what we're used to, IAM roles, IAM users, to our Kubernetes cluster. And that's done by a project, an open source project called AWS IAM Authenticator for Kubernetes. It was started by a company called Heptio. Now it belongs to the Kubernetes SIG Foundation, and it's been worked on by Heptio, VMware, AWS themselves. And this is how you can map these two worlds. So the configurations for this lives in the config map in your Kubernetes cluster. So every time you create an EKS cluster, this auth config map gets created for you automatically. And you can see here, you're just mapping accounts, mapping roles, and mapping users. So in this map roles, I can say, hey, this role on has this group, because obviously in Kubernetes and RBAC, you can have groups which are linked to service accounts. And a service account is basically just like an ID on Kubernetes, like, hey, I belong to service account A, so my name is A. You can think of it like that. So this config map basically just is how you map Kubernetes groups to role on. So it doesn't have to be groups, it can be service accounts, it can be users, so forth. By default, you'll see all your nodes will by default be on this config map because your nodes need to connect to your cluster as well. So I can add ArgoCD role here to allow ArgoCD to connect to other clusters. But now, how do we give ArgoCD? So now we know how to connect to EKS. How does ArgoCD, which is an application as a pod, assume an IAM role? This is where we get a terminology called EKS IRSA. So it's IAM roles for service accounts. Basically, EKS allows you to have the ability to give a pod, let him assume an IAM role. And the way this does this is we set a pod, every pod in Kubernetes has to be linked to a service account. So a service account is an ID, so we're just identifying this pod. We can tell the service account, hey, this service account, you can assume this role. When you deploy this pod, under the hood, there's another controller which sits on the EKS control plane, which then sees, hey, this pod belongs to a service account. This service account is allowed to assume this is linked to this IAM role. Let me inject some AWS credentials. It does. You'll see there's a admission controller on Kubernetes which mutates, which changes your pod, and we'll show you that. It actually changes your pod and injects some credentials onto your pod that then your pod, which ArgoCD can use to access the Kubernetes cluster. The reason IRSA is so useful because it does least privilege, because you can assign a specific IAM role to a specific pod. In the olden days, you would have a variety of ways, but you would let the application assume the role of the node or the EC2, and then basically you would have to let your EC2 have many permissions in its role, because maybe you had an application that needed to talk to S3, you had an application that needed to talk to EKS, you had an application that needed to talk to RDS. With the node, the EC2 would need all their permissions, but now you can have different roles for different applications, so it's least privilege. You can isolate your credentials and its auditability. So every time my pod uses its credentials to access AWS, this gets logged on CloudTrail, and we can see all the information what's going on there. So, oh my God, no, next slide. Oops, whoops. So where are we? So this is the service account for ArgoCD. Yeah, remember I said the service account is like an ID. I've said, hey, you attach this annotation. You can see it says EKS role on, and then you give it the role that it needs to assume. Then when I deploy ArgoCD, there's EKS, the control plane sees this and actually changes my pod and injects environment variables to it. Like you'll see my pod, I don't specify and get that these environment variables exist, but they get injected by EKS first. And you'll see there it has an AWS web token file. And any AWS SDK knows how to read this file, produce it, gets this JWT token, and then it can assume a role through EKS. So that's how ArgoCD can get credentials. So I quickly going back to the code here, you'll see here, I have two duplicate quickly. I have two clusters. I have a ops and a dev. So ArgoCD, what we've done so far, is sitting in the ops cluster. It needs to connect to my dev cluster. I've created an ArgoCD IAM role. You'll see it actually has no permissions because it doesn't need any AWS specific permissions. It just needs a role that we can map to Kubernetes permissions. Yes, sometimes you need ArgoCD, you need like applications to use ISA to connect to S3 RDS. That's when you would grant it, yeah. But for EKS, it just needs to be able to assume a role, and then you tell that AWS auth config map, which we've spoken about for, hey, this role is allowed. And a nice added benefit, it's good to basically limit who can assume this role. Because so if I go to my infrastructure, which I've done in Terraform, this example, EKS dev, you'll see I've changed that config map. And I've said, hey, this Mzansi role can connect to this cluster, and when it connects, it can be system master. Basically, you don't have to do this, but you wouldn't do this in a production environment. But for today, I said, hey, Argo can be an admin on my cluster. So by doing this, you obviously don't want anyone to be able to assume this role, because whoever can assume this role as system admin master on my dev cluster. So you'll say, hey, only someone who assumed a role through this ORDC provider, which comes from the EKS cluster, and has this service account, which is ArgoCD, is allowed to assume this role. So no one else can assume this role. So you can be very certain that no one else will assume this role. Cool. So if we had to quickly go back, if I wanted to just quickly, I will quickly connect to my dev cluster just to show you. I'm on it now. Cool. So this is the barebone dev cluster. This is that auth config map that I told you about. And you see when I applied it to Terraform, it added this map role. So it's mapped. Anyone who comes with the credentials has assumed this role is now system master on this cluster. Cool. So now on ArgoCD, let's add this. So I'm gonna, so in ArgoCD, as I say, everything is declarative. So you'll see it. ArgoCD, you just create a secret. You add a label saying, hey, the secret is an ArgoCD cluster. And then you just tell it, hey, it's an AWS auth config. So then this will tell ArgoCD, hey, use the AWS SDK to connect to this cluster. This is what you're telling ArgoCD. You give it the URL where the cluster is, the name of the cluster, and this is the CA certificate and insecure. But this thing tells ArgoCD, hey, use the ArgoCD SDK. So I'm just gonna remove that. So if I had to do status, we're going to say, and that's the wrong file it's added, but anyway, git add. This guy. Git commit milestone. Add dev cluster to ArgoCD. So that should have pushed us. If I have to go back to ArgoCD quickly, I can't see it yet. I'm sorry. Zoom is basically taken over. If I had to do a refresh here, it should say out of sync, because now we've added a secret, which is a cluster. Yep, out of sync, and you'll see it tells you who pushed it. Last thing is that you can click on this, it'll take you to Git, it'll take you to the commit that I changed. So it's very Git orientated, which is quite nice. If I hit to app diff, you'll see it'll tell you, hey, this is the secret you want to deploy. That's a cluster. So if I sync this and I sync this. Cool. So if I have to go to settings, clusters, you'll see there's a new cluster, AWS and then did. Right now, the credential type is using IAM auth. The reason it's using that is because in this config, we told Kubernetes, we told ArgoCD, sorry, hey, there's an AWS auth config. That's how you connect. Right now, the status is unknown because it hasn't tried to deploy any applications to it. Now we want to, and I can't remember if, so let's try, I have a cluster that's ready actually. Obviously apps, just clear this to, nope. I want to.
While you navigate to that, Kelvin, in the interest of time, I think I'll just pose some questions maybe to also get the, the group started. What would you say are the top 3 skills that you would say a DevOps engineer needs to have? And secondly, there's often confusion between what an SRE engineer and a DevOps engineer is. Do you mind maybe just taking us through what's the difference?
Sure. So DevOps, DevOps engineer, is actually it's a set of practices. So it's kind of been coined as a title, but there's a lot of confusion because DevOps is actually more of DevOps came about when cloud came about of how to link the gap between developers and sysadmins. And the Cloud Native Foundation came up, and we started writing our infrastructure as code, and we started bridging the gap between developers and sysadmins. And then this is where a set of practices like GitOps came about, where infrastructure as code came about. And all these sets of practices came, containerization, Kubernetes, all of them came about, and they all fall under the DevOps principle, terminology, or set of practices. And a site reliability engineer is, as I said, a site reliability engineer. You are responsible for maintaining it. So you are the one that deploys the infrastructure and maintains, bridges the gap for the developers. Because as you can imagine, Kubernetes itself is a beast on its own. To learn Kubernetes we can't expect all application developers to be Kubernetes experts because they have their own sets of, their Java developers, they have their own practices to they have business priorities to learn. So SREs are the ones who are maintaining this foundation to allow them to deploy their apps. So we are the ones who configure, manage, write custom controllers even to bridge the gap between developers and the infrastructure. And one of the places where SRE is becoming very big is we're trying to bridge the gap of how can developers write their code in a fast and efficient way and get it deployed quickly. And this is the area I'm particularly focused in, is called internal developer platforms. Us as SRE developers, we're trying to create ways for developers to write code and let them get tested as fast as possible. You can imagine in a massive organization, let's say you have a microservice design where you have 50 applications in your microservice. You can't expect a developer to run all 50 applications locally to test his code. We are continuously trying to think of ways, how can we speed up the process of this developer to write his code, to build it. So we want to create efficient pipelines. And on top of all that, we're running this in the cloud. How can we do this without racking up a $50,000 bill? So those are the main things that, as an SRE, even a DevOps engineer, which we'll call it today, I believe you have to be able to context switch a lot, because you're doing a lot of things. You're thinking about cloud, IAM roles, costs, applications, containers. Sometimes you'll even get involved in databases, which probably will. You'll get involved in logging. You'll get involved in monitoring. So
yeah,
you need to be able to context switch often.
Yeah, it definitely seems like a lot. I think we definitely need to have you back, Kelvin,
Sure.
For another session so that we can have a deep dive into this. I think we've basically run out of time now, but in closing, what would you say, what would you say to someone who's looking to start their career in DevOps or SRE, and what should they take away from this session today? Just some, 5 points that would be very important as they start to look at ArgoCD and what it can, provide for them, or how it can improve their current processes. And for anyone who's looking to, get into DevOps or even SRE.
Yeah. So yeah, I would definitely start off with AWS. AWS is still in the world, it's the biggest cloud where most companies are running their applications. So getting certified in AWS is a very good start. Learning all the different tools, like what IAMs are, what S3 is, compute. And then the next step I would say is to get into containers. Containers is the vast majority of the way big companies are running their code today. So learning Docker. Once you understand Docker, then okay, you pick up and you understand what a Docker image is and how to build a Docker image into containers. Then you can do a jump up to Kubernetes or even ECS, which is AWS's container operation. So once you've understand that, we can then jump on AWS. Then we know how to host our platform. Then we learn about the actual computer of it, which is EKS. once you get into that, then it's start looking into like how to do performance or how to do monitoring of your applications. But I would say a good start is, and then after AWS, obviously, when I'm saying AWS, you have to also include how to deploy things to AWS. So learning things like Terraform. How do I actually deploy an EC2 instance? How do I create an S3 bucket? You can't imagine in a big organization, everyone creating things manually. Click, click, click. We call it click ops. We don't want to be click ops engineers. So IAC, infrastructure as code. That's a really good one to do. So either be Terraform, Pulumi, a variety of tools. So if I had to take three things away, it would be cloud, infrastructure as code, and containers. Docker, learn Docker.
Cool. That's super awesome. Thank you very much, Kelvin, for sharing those super cool nuggets with us tonight. And if anyone else has any questions, please feel free, guys, to unmute yourself and also, just to give a thumbs up to Kelvin for, giving us his time tonight and sharing his insights.
Yeah, sorry, I know I ran out of time, so yeah, I don't mind saying extra if you guys have questions, and as long as you need, I can answer the question. Yeah,
I think this has been a very good session, and I think it's something that could be modeled into a workshop and take you guys through, because I think the session is too short to go deep, into the inner workings of what ArgoCD can provide. And we can also even have a poll on the guys that want to have, this session extended to a workshop, and then, we can have you can have me back with us, please, if you will give us your time, Mr. Kelvin.
Definitely.
Excellent stuff. So in closing, guys, anyone have any questions?
Yeah, I have a question for you, Kelvin. Steven, yeah. So should all your applications be running on Kubernetes, or only a subset of them for you want to use ArgoCD? So for instance, let's say you're running on AWS and have a mixture of Lambda, EKS, or some other EC2-based workloads. Would only having a subset of them running on Kubernetes, would that be ideal for the use of ArgoCD, or would you need something of a multi-cluster management at scale for you to use ArgoCD?
So yeah, so ArgoCD is only designed to manage applications that are on Kubernetes. So if you had things like Lambda or ECS, you wouldn't be able to use ArgoCD. So in terms of should you run everything in Kubernetes, I wouldn't say so. Obviously, each application does have different use cases, but in the world where in 2023, the most popular thing is microservices, the best place to run microservices is in Kubernetes, in my opinion. And then if you want to deploy to Kubernetes, the best way to do it is via ArgoCD. So there's many ways to deploy application, but if it's going to go on Kubernetes, ArgoCD is the way, in my opinion.
Thank you.
Sure.
Cool. I think those were the only questions, Kelvin. Thank you so much for joining us tonight, and definitely.
Yeah, thanks, Kelvin.
Anytime.
Yeah, man. We look forward to having you back. Hey, I think next time you must explain to us how you jumped from being a Java developer and then you ended up in Golang, and how did you get sucked into Kubernetes? Show us some of the stuff you do in the open source space.
Yes, sure. Yeah, I'd love to show you the projects I'm working on now. Yeah.
Awesome. Cool, man. So yeah, that's Kelvin, everyone. And and how is living in Malta? I mean, you are from you were here in Joburg with us not so long ago, and then you just left us and went to Malta.
It's great. Well, not today. Today is extremely hot. I know it's winter day in South Africa, but it's extremely hot right now. It's like 30 degrees and the humidity is like 70%. So like imagine like Durban, but like times 10. But it's great. Lots of ocean. Very small. Like I said, you can get from the whole country in a car in less than half an hour. It's small, but it's good.
Awesome. Cool.
Cool.
That's it. And anything else from you, Togo? I'm done.
From my side, guys, Kelvin is also in the WhatsApp group. So if you would like to pose some additional questions to him, please send them through in the WhatsApp group. And
Cool.
thank you and good night.
Thank you. Goodbye, everyone.
Ciao.
Cheers. Thanks, Kev.